Hey everybody, it's Unit 4, Video 8. This is Miss Moran, and we're going to be working on radical expression operations. We're going to do, for this video, we're only going to be working on adding, subtracting radicals, and then multiplying radicals as well. And in class, we'll get a chance to do a little bit more rationalizing and some dividing. All right, so a couple examples to start with when we're adding is we're actually going to start by adding radicals that have the same radicand. And let's go ahead and take a look at an example. So I have 3 times the 4th root of 11pq minus 7 times the 4th root of 11pq. Now, because they have the same radicand, then I can go ahead and just subtract them or add them together like terms. For this, I would use 3 minus 7 to give me a negative 4 as the multiplier in front, and that is still the 4th root of 11pq. My radical didn't change, and I remember making sure my index is there, or otherwise you've changed from a 4th root to a square root for no reason. Let's try another one. Okay, so example B here, I'm going to go with the square root of 98x to the 3rd y plus 3x times the square root of 32xy. Now, as we look at these right now, the radicands are different, and I will need to see if I can get them to be the same before I'm able to add these together. I'm going to grab a different color here so you can see what we're going to do in the next step. So 98 is actually 49 times 2, and then this is x cubed times y. Over here, I'm going to have 16 times 2 and an xy. Well, because I'm working in square roots for this problem, I'm looking for perfect squares. So I have 49, I have a perfect square of x's. Over here I have a 16. Everything that I'm circling, I'm going to take the square root of and place that number on the outside of my radical. So this first part is going to simplify to 7x. The parts that were unable to be reduced or simplified because they are not perfect squares will remain inside of the radical. For the second part, I've got the square root of 16. What I have to remember is I have to multiply that by the coefficient that's already in front of the radical, which will give me 12x times the square root of 2xy. Now that my radicands are the same, I'm able to add the coefficients together. So if I add 7x plus 12x, I get 19x, and then the square root of 2xy. Let's try another one. Okay, so for this example, let's go ahead with the cube root of 64 m to the 4th n to the 5th minus the cube root of negative 27 m to the 10th n to the 14th. Because I'm working with a cube root, I'm looking for perfect cubes. So I need to be certain that I'm not thinking in the square root idea, but I'm looking in the perfect squares, but I'm actually looking for perfect cubes. So 64 is actually a perfect cube. It is the perfect cube of 4 cubed. And then I'm going to have m cubed with an extra m and n cubed with an extra n squared. For this one, negative 1 is actually a perfect cube, and so is 3. So that makes my negative 27. And then I have m to the 9th and an extra m, and n to the 12th and an extra n. So I'm going to change colors again here because I think this part's really important. I can only take out the perfect cubes, and anything that's not perfect will stay inside. But this here is actually m cubed cubed. So there's going to be 3 of these being removed. And the same thing, I've got n to the 4th cubed. So it's my n to the 4th that will be removed. So starting with the first one, I'm going to have a 4mn. Then I'm going to have a cube root of what's not perfect, and that's the m and the n squared. Oops, that should be an n. Okay, minus, over here I'm going to have a negative 3, which actually turns that to a positive 3. followed by m cubed and n to the fourth power, and that's because of my n to the fourth is what is actually being cubed. What remains inside the radical is the m and the n. N squared. I had 14 total there. Oops, forgot it up there. So n squared. Now, if you look, your radicands are the same. You have under both of them mn squared, mn squared. However, with the coefficients being different, it's best to leave them separate because those are not able to be combined very easily. Another thing to point out is when you have all these variables with exponents on the outside, and then you have this index, be very certain that it's communicated well to whoever's grading your paper as to what's an exponent on a variable and what is left to be a index for the radical. Oh, excuse me, that scared me. If you saw me, I jumped. So again, make sure that you can see the difference between the n to the fourth and the cube here, and then on this side as well. So take a look at that and be very careful. All right, multiplying radical expressions. When we multiply radicals, we just have to be certain that we're multiplying the outsides, like the coefficients together, separate from when we multiply the numbers under the radicals, our radicands. And let's go ahead and take a look at that idea. So we're going to start with 1, and it's a special one because these are actually conjugates. And a conjugate is when we have the difference is just that plus or minus between the binomial here. And we're going to use a double distribution idea. If you like that F word, you may use it here as well. But I'll go ahead and just distribute here. So that's going to give me root 7 times root 7, which you may write as 7, or some of you may go ahead and write it as 49 and make this 2 steps. Then I'm going to have plus the square root of 70 minus the square root of 70, and then lastly I will have minus the square root of 100. To simplify this, we'd have 7, those would cancel each other out, minus 10 for a final answer of negative 3. And this happened to work out nicely because I was able to eliminate my radicals. This is a technique that we would use if we were trying to rationalize this binomial out of the denominator. Let's try another one. For this one, let's go with the square root of 2 plus 3 times the square root of 8 minus 5. Again, we're going to use the same idea of the distribution. So go ahead and start distributing if you'd like. We'll have root 2 times root 8 gives us the square root of 16. We'll go back and simplify later. Minus, and the 5 on this one stays on the outside, whereas the radical 2 stays the same, plus 3 radical 8 minus 15. Let's simplify as much as we can. This is 4 minus 5 radical 2, and this radical 8 can actually be simplified to 2 root 2, multiplying that 2 by the outside, so 6 root 2 minus 15. Lastly, I'm going to combine all my like terms. This is going to give me 1 radical 2, or just a plus radical 2. And my 4 minus 15 gives me a negative 11. So that would be my final answer for this one. All right, let's try one with some cube roots on it, since we haven't looked at any of those. So let's go ahead and try, how about the cube root of 25 minus 4 times the cube root of 5 plus the cube root of 2. Okay, so I'm going to start by distributing, and then we'll clean it up as we go. So this is going to give me the cube root of 125, and then I will have the cube root of 50, followed by negative 4 cube root of 5, and lastly negative 4 cube root of 2. So I'm thinking that I can probably simplify this first one up here. The cube root of 125 is 5. And then if I look inside of 50, remember my cube roots, or my perfect cubes, are 8, 27, 64, so I'm not going to find anything that's going to help me reduce with a 50. So in fact, the remainder of this will actually stay and look just long and messy, but it's actually perfectly correct. There's no right order to write the rest of these radicals in, so this is an acceptable answer. So there is all of kind of an idea with distributing, and you just have to look for perfect cubes rather than perfect squares as we have in the previous problems. Alright, so after you've watched this video and tried the problems on page 74, numbers 59 to 73, just be certain that you understand the idea of adding and subtracting radicals when they're like or when they're different, and also making sure that you can multiply and then reduce the radical to get your simplified answer. So all of these problems are odd, so you should be able to check them in the back of the book. And when you come to class tomorrow, we'll be working on some rationalizing and some fractions, and using that idea of the conjugate in order to get the radical out of the denominator. See you tomorrow.